Good morning. This is Trigonometry 5.1, lesson number 4. I've got some good news for us. No more calculator problems. Look at that. Now we're using the correct calculator, so that's going to be nice. I'm going to use that for this lesson. Come back to that in a moment. This lesson, we're not learning any new trigonometry. It's just a little bit of equations. Just a little bit of equation. So it's the same trigonometry as the previous lessons, just with a little twist in the solving because the x or the unknown's in a different position. So let's get into it. I'm going to make myself small and we'll just go through these examples here. And the questions are up there. Exercise 3G. Have a go at those. Oh, I wish I could get that exactly the right size. Exactly the right size. There we go. Okay, so exercise 3G. Let's get this over here. What we have so far, we've solved equations that look like that, where the x is on the top. In this lesson, we learned to solve equations that look like this, which is almost exactly the same, except the x is now on the bottom. And we don't need any new trigonometry, we just need some equation skills. So let's see them. So for the very first one, this is what you've been doing so far. 0.7 equals x on 5, and all you did was times both sides of the equation by 5, and you get 5 times 0.7 equals x. That's what we've been doing so far, and then use your calculator to find out what the answer is. In this case, you don't need to. 3.5. Well, a bit more room here. It's a bit cramped. But now, what do we do if the x is on the bottom? Going to need an extra step. So I'm going to start off. I'll start off with that same timesing by what's on the bottom. In this case, it's x. So we get x times 3.2 equals 11. But now, x is not by itself. So we're then going to divide by 3.2. Divide by 3.2. And you get x is 11 over 3.2. Now I'm going to fix up those colors, make it easy to see what's going on. So the steps, that didn't, unintentional. What we're doing is 2 steps rather than 1. 2 steps rather than 1. This color selection is not going well. Complete failure. We'll leave it like that. 2 steps rather than 1. Now, some people will do it this way. They will just take a shortcut and they'll go 3.2 equals 11 on x. And so they'll say x is 11 on 3.2. I'll just go straight from there to there. If you want to do it that way, yeah, you can. But I like to make sure that everyone knows the underlying steps. So let's example number 3. Now we've got tan 85 in there, which can make people a bit nervous because it's new and it's different. But tan 85 is just a number. So if I put that in the calculator, tan of 85, I always like to close the bracket, just habit. It's just a number. It doesn't look like it's just a number. It looks fancy. It's just a number. So therefore, we can treat it as if it's just a number. We don't need to do anything special and do the same step as before. So let's do it properly this time. Times by x, which gives us x tan 85. I will put the times in there, but you don't have to. Equals 90. And then divide by the tan 85. Let's move that across a bit. Divide by the tan 85 on both sides. So, therefore, x is equal to 90 on tan 85. Hey, that last question, I didn't finish it off. I got up to 11 over 3.2 and I stopped. That's pretty silly. 3.4375, which was, let's just say 3.4 to 1 dp. But for this exercise, this question, 90 over 1085 is equal to that. 7 point, and I will write the full thing out. 7.87. 397. 717. That doesn't right. 3.873, 979, 717. And say the two decimal places, 7.87 to 2 dp. That is a nice way to do it. Nope. Moving on. Now, you don't have to do it in so many steps, right? So you could just cut out the purple bits and just do the orange. That's fine. You don't need to write those steps if you don't want to. Hey, I'll keep it going. I don't want to drag this on because it's the same as previous lessons. So just do a couple of examples here. The full thing, start to finish. So step number 1, trying to find x here. Let's label our sides. That's our hypotenuse. That's our opposite. That's our adjacent. Which ones do we care about? Those two. The hypotenuse does nothing for us. So we go at SOHCAHTOA. Which one are we going to use? Well, we've got the opposite and the adjacent. It is tan. Color change not working today. There we go. So I'm going to write tan of 20 degrees is the opposite over the adjacent. So tan of 20 is equal to 4 on x. Then I'm going to take the x over there. I'm going to skip those steps. We'll actually write down times by x because it gets too ugly. And then x equals 4 on tan 20. Then we go calculator. Oh yeah, last time I was using the divided by symbol. But if you want to do it as a fraction, whatever, that's cool. Same thing. X is equal to 10.98990968. Shoot, dot 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 goes on forever. We only want, say, 2 decimal places, 10.99. 2 dp. Hey, that's how you do it. Gonna scroll down. And 3, 2, 1. Next one. Same thing here from the top. We get some different colors happening. Hypotenuse. Ugh. That's our opposite. That's our adjacent. These are the ones we care about. So opposite and hypotenuse. SOHCAHTOA. Opposite and hypotenuse. Sine. Sine of 53 equals opposite over hypotenuse. I always write that to make sure I do the substitution correctly. So I really check it and I say opposite is definitely 26 and the hypotenuse is x. It just avoids making mistakes. Hey, I'll still do it the long way. I was thinking of taking a tan. That was the last question. I was thinking of taking a shortcut, but I won't. 26 on sine 53. Calculator. Ooh. 32.5555. Unusual. 2711. And 32.56 to 2 decimal places. Ta-da. There's a question in your book, you can see here, which tells you to find both x and y. So you can do it trigonometry in 2 steps, or we could find the y and then just use Pythagoras, well, which I am actually thinking of doing. just as a reminder that Pythagoras is sometimes useful. I purposely chose this one because it's got the 2730. So I haven't talked about this in a video so far. If I have something like 27.5 degrees in decimals, 27.5, there's actually another way that we can write it. And the way is, if I press this button here, you can see that is like that. We call it degrees, minutes, seconds. So it's 27 degrees, 30 minutes, 0 seconds. So just like we split up the hour into 60 minutes, we're splitting degree into 60 minutes. So when we had 27 and a half, what's half of 60? 30. And the calculator does this for you very quickly. Any degree you want. So if I'm just randomly pressing buttons here, 52.77453 degrees is 52 degrees, 46 minutes, and 28.31 seconds. Now, when you're rounding, you got to be really careful here because it's half of 60 is 30. So 30 is our cutoff. So if I'm rounding to the nearest degree, you think, oh, look, it's under 50, so it's 52 degrees. No. We are 30 or over. We got to round this baby up to 53 degrees. And you can see that easily. If I press this button, you can see, yeah, it's definitely way closer to 53. We definitely got to round up. So when you're in this degrees, minute, second mode, be careful with the rounding here. If I had to round to the nearest minute, I look at the seconds and say there's only 28 seconds. It hasn't hit the 30. So to the nearest minute, that would be 52 degrees and 46 minutes. But let's see how we solve problems with it. I'll leave that up. Let's just solve this one here. Drag that one down. If it wants to move, that would be great. Ooh. Technical issues this morning. There we go. So I'm going to find y first. And so for that, we got, this is our opposite. That's our adjacent. That's our hypotenuse. So I want to find y. So I'm going to start with those two, opposite, adjacent. It's tan. So I'm going to skip writing SOHCAHTOA. In a test, you don't really have time to write SOHCAHTOA more than once. You can write it like the start of the exam, write it once, and then that should be enough. So tan of 27 degrees 30 minutes equals 9.6 over y, and I'll put that decimal point in the right spot. Yes, and we put 1 dash for degrees and 2 dashes for minutes, as you can see on the calculator there. And then we go y tan 27 degrees 30 equals 9.6. Y equals 9.6 over tan 27 degrees 30 minutes. Now, this is where the calculator comes in handy. We got 9.6. I'll use this one. Brackets of the tan. And it's 27, and I'm going to press that one. 30, and then press the same button again. I know it looks the same. It looks like 27 degrees, 30 degrees, but the calculator understands. That's 27 degrees, 30 minutes. And close the brackets. So those brackets are useful there. We can see it's tan of that whole thing. And got an answer. We found y, which is 18, when this is a side length, remember? 18.4414, 2842. Let's go 1 dp, 18.4. Now, to find x, what you could do is, well, that's adjacent and hypotenuse, you could use cos. So you do the whole thing. Cos of the 27 degrees 30 equals 18.4 over the x, and go from there. I would not recommend doing that, because we've already rounded this to 18.4, and then so your answer for x is going to be a little bit off. If you're going to find x, what you should do is still use the number you've got, the 9.6. So definitely for finding x, opposite hypotenuse, use sine. So sine 2730. And this time I will take the shortcut, so 9.6 on x. So x is 9.6 over sine 27 degrees, 30 minutes. And let's put that in the calculator. 9.6 over sine 27 degrees, 30 degrees, 20.7905. 7905. 3347. And that's how you do it. So, very small change there. I put in the degrees, minutes symbols, degrees, minutes, second symbols. But that's the same thing. Just scroll up so you can see that whole thing. So there's two of them. Now, I didn't mention you could have used Pythagoras to do it, which is after you've got 9.6 and y, you could say, I'll just put in red over here. You can say, oh, x squared is equal to y squared plus 9.6 squared. To do it right, without any rounding, I would substitute in not 18.4, not 18.4414842. I'd put in the original. I'd put in the expression. It's 9.6 over 10 27 30 squared plus 9.6 squared. Now that, yeah, looks kind of scary, right? To put all of that in your calculator. But calculator can handle it. So 9.6 over 10 27 30. So that's the first thing. Square it plus 9.6 squared. So long it doesn't even fit in. But the square root of that plus that squared. Moment of truth. Expecting 20.79. Well, that's just great. What have I done? Oh, because I didn't close the bracket. There we go. Round two. Close the bracket. There we go. Proof. Same thing as before. 2. Look all the way to 20.7905. 3347. Look at it. It's the same number, same decimal places as the other one. Exactly the same. I recommend just using the trig, actually. Look at that. That was way harder. Cool. Okay, so quick review. What you need to be able to do. Same process as lesson 2. This is just copied from the lesson 2, the steps. You can go back and show it to if you want. But it's the same process. Recall the definitions, label sides, identify the ratio, form the equation, make the unknown the subject, use your calculator, round it. Whew. The only thing that's changed is step 5 here. Make the unknown the subject. Make the unknown the subject. We had to do this little trick. Hey, I'm going to stop there. Video's long enough. Questions, I'll scroll back up. 3, 2, 1. Here are your questions. 1, these are just the ones on the left. 1, 2, 3, 4, left-hand side. And then 5, 6, 8. Okay. Well done. Bye-bye. Good luck.